2.3 part 2, we're going to continue using our long division and synthetic division, but now we will find what are called rational zeros, things that can be written in a fraction form. So things that you might think of that are rational are the integers, 0, 1, 2, 3, 4, -1, -2, -3, but also rational numbers, so 1/2, 1/3, things that can be written in the form of a fraction. So the first thing we're going to do is we're going to take this equation right here and we're going to put it into our calculator. So I've typed my function into the calculator. I look at the graph. You can see it looks like it's hitting -1, 2, and 4. So those are the numbers we're going to start with. We're going to do some synthetic division on -1, 2, and 4. So if I start by setting up synthetic division, 1x cubed, -5x squared, 2x, and the 8. And again, we'll start with that -1 that we saw on the graph. So the 1 will drop through. We have 1, multiply on the outside, -1, add on the inside, -6, multiply 6, add 8, multiply again, -8, and we get a remainder of 0. So that one's working. So again, if we go back and look at the calculator, it looks like 2 and 4 are other zeros. So I'm going to just continue right where I left off, and we'll do a 2 out front. 1 times 2 would be 2. That would add up to -4. 2 times -4 is -8. And I got a remainder of 0. And then that last number we saw was a 4. So I could even do 4. So the 1 drops through. 4 times 4, 1 is 4. And I got a remainder of 0. So my answers, my solutions are -1, 2, and 4. Now, when you take the test, you can't just look at your calculator and say, yep, those are the zeros. This is the proof that those indeed are zeros. So the second example, same thing. We're going to go to the calculator, type it in. So after you've typed into y1, again, look at the graph. And now when I look here, it looks like maybe it's something between 0 and -1. So that one's going to be hard to find. So let's take a look at what we can do to get this one. So in this particular problem, we may have to create what's called a P over Q list. So P and Q. P would be the 4. So what are the factors of 4? 1, 2 times 2, and 4. And what are the factors of Q? That would be the number 6. And the factors are 1, 2, 3, and 6. So when you make your P over Q list, simply put all the P's over all the Q's. P and Q. So what's 1 over 1? And I'm going right down the list of the P's. So I'll go 2 over 1 and 4 over 1. So 1, 2, and 4. One of the things we will do is make this list all plus or minus, all the positives and negatives. But I did not see any of those nice numbers. Then I'm going to go 1 over 2. 2 over 2 is 1 again, so I don't need that. And 4 over 2 is also 2, which I have in the list. Then the next numbers will be 1 over 3, 2 over 3, 4 over 3, and then 4 over 6. 4 over 3. We did that. So 1 over 3, 2 over 3, and 4 over 3. Then the last ones would be 1 over 6, 2 over 6, which is 1/3 already in the list, and 4 over 6, which is 2/3 already in the list. So that would be all my P over Q's, what we call possible rationals. Now you might not think that these numbers are nice, but mathematically, because they are rational, we do say that they are nice numbers, and we can do our synthetic division. So that one number, again, on the calculator, looks like it might be -1/2 or -1/3. So let's do those. So I'm going to set up synthetic division. I'm going to do 6, -1, 9, and 4. And I'm going to try -1/2. So the 6 drops through. Half of 6 would be -3 here. Add those together, I get -4. A negative half of -4 is +2. Add that up, that's 11, and then you'd be -5.5. But you can see your remainder did not turn out to be 0. So let's try it again. Maybe it's -1/3. So 6, -1, 9, and 4. So the 6 will drop through. -1/3 of 6 would be -2. Add those together, I get -3. -1/3 of -3 would be a +1. That would be 10. And that, again, would not get me to a remainder of 0 because this would be -10/3. It won't be 0. So again, knowing that on the calculator, this graph is passing between 0 and -1, the only other number in our list that's a fraction that can be between 0 and 1 is 1/6. So if I try the 1/6 out front, and I do 6, -1, 9, and 4, the 6 will drop through. 6 here, 1/6 of 6 is 1. -1 and 1 is 0. 1/6 of 0 is 0. 9 plus 0 is 9. And 1/6 of 9 would be 9/6 or 3/2. 3/2. And that's 1.5, so you get a remainder of 5.5. What this tells me is that the 0 that's between -1 is not nice. No rational solutions. So in that case, we would have a hard time solving this. We'd have to use some other techniques. In example 3, doing the same thing, we're going to go to our graphing calculator. I've already typed this in. So there's my x cubed plus x plus 1. So this is the graph. Again, it's crossing between 0 and -1, so it must be something other than an integer. Might be one of those rational numbers again. So if I do the same thing with the p over q, my numbers for p, that would be a 1. The only factors are 1. Q is also 1, so the only factors are 1. So my p over q list would equal plus or minus 1. Well, clearly my graph does not hit -1 and or 1, so there are no rationals again. We don't even have to do any work on this problem. We can just say there are no rationals. So in this example, all right, finding the zeros, all of the real zeros of a polynomial function. So we're going to continue with the same thing. We'll revisit the quadratic now. So again, let's go ahead and type this into our calculator. So I've typed the function into my graphing calculator. I look at the graph, and it looks like it hits somewhere between 0 and 1. So 0 and 1. So I'm going to go back here, and if you did a P over Q list again, you're going to find that 1/2 might be a number. So let's try 1/2. So I do 8, -4, 6, -3. I do 1/2, So the 8 will drop straight through. Half of 8 is 4. Negative 4 and 4 is 0. Half of 0 is 0. 6 plus 0 is 6. Half of 6 is 3. And I get a remainder of 0. But now I'm left with this, which is a quadratic. It's 8x squared plus 6. So this one, I could do the quadratic formula, but I can also just solve it directly. So I can subtract 6. And I get 8x squared is equal to negative 6. Divide both sides by 8. X squared is negative 3/4. But what happens when I go to take the square root? Can't take the square root of negative 3/4. So the only real solution is x equals 1/2. To do something like this, we're going to have to use complex, which is in another lecture. All right, so I've typed this next equation into our calculator, and you'll notice that everything has an x. So right away, we should know that if I put 0 in for x, I'll get an output of 0. And if I look at the graph, right there, it looks like it's crossing at 0, maybe a negative 1, and maybe a 2. So let's try a couple of those numbers and see what's happening. So in this problem, one of the very first things I would do is I would factor out the x. So that will leave behind 10x cubed minus 15x squared minus 16x plus 12. Now we could do a p over q with this thing if you'd like to find that one that's in between. But I already know one of my answers is 0 because of this. Now I can do synthetic division with what's left over. 10, negative 15, negative 16, and 12. And so again, just double checking the graph, you can see maybe negative 1 and 2 are answers. So let's take a look at those. Negative 1, so that would be 10 drops through. I get 10, I get negative 5. Oh, negative 10, excuse me. So negative 10 and negative 15 is negative 25. So this will be 25. So then that's 9, and this would be negative 9. I'm getting an output of 3. So negative 1 didn't work. It looks like it, whoops. It looks like it works on the graph, but I'm getting an output of 3. So obviously it did not work. So let's look back at the graph. Let's maybe try the number 2. So hopefully 2 would work. So I can do 2 out front, and then I do my 10, negative 15, negative 16, and 12. So the 10 will drop through. That's 20. Add those two together, you get 5. Multiply, you get 10, negative 6, negative 12, and I get a remainder of 0. So now I know one of my answers is 2. So I have those two answers. So the last step then would be to set up the quadratic formula. So remember, this is your remainder, constant, x, and x squared. So that's my quadratic. This is my a, that's b, that's c. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which is 2 times 10. So negative 5 plus or minus the square root all over 20. Now under the square root, you can type this all into your calculator, but you have 25 plus 240, so you end up with 265. So that, to me, those are real numbers. In this problem, we're supposed to be looking at finding the real zeros. So these are real. You can find them. They're decimals. But I would just write those down so we can basically bring these two answers up here. So remember, the quadratic formula has plus or minus here. So there are two answers here. So we have 4 answers for this x to the 4th. The next one is a DIY. So go ahead, graph it. Do some synthetic division, at least get down to the quadratic that you could do quadratic formula, and let's see what your answers are. So go ahead and pause the video now. So if you graph this equation on your calculator, you probably saw that it hit at -1, 1, and 2. So just keep doing synthetic division. Don't reset. Just go right underneath, do the next one, do the next one, do the next one. So you have 3 real zeros right here. Now the bottom, this is a quadratic. That's your A, B, C. So put them into the quadratic formula. And then you'll notice right here, most of us get to this step. And the simplified version is to split 40 into the square root of 40 and the square root of 10. What is the square root of 40? It's 2. So now, what's -2 over 6? And what's 2 root 10 over 6? Both of these are 1/3. So you have -1/3 plus or minus root 10 over 3. So there are 2 answers here. So we found all 5. The last page of the notes would be some more practice. Let's do this one as a DIY. Oops. So go ahead and set up synthetic division and go through that process, and then let's take a look at your answer. Pause the video now. So setting up synthetic division, depending on how you do it, you may have the box like this, but we ended up with a remainder of 6. So you put your coefficients across there. Remember, this is x plus 3, so that's the factor. The value is -3, should get a remainder of 6, so it is not a factor. All right, so number 2, I'm going to walk you through some long division. So with this long division, it would look something like this. I would take my 4x to the 5th. Let's go ahead and put 0x to the 4th in there as a placeholder. Minus x cubed plus 2x squared minus x. And we are dividing by 2x plus 1. So my first step would be to take that 4x to the 5th. 1, 2, 3, 4, 5. And we are dividing by 2x. So I can get rid of one of the x's. 4 divided by 2 is 2. So I'm going to write 2x to the 4th up top. Multiply by everything out front. So 2x to the 4th times 2x is 4x to the 5th. We want those two to be the same. 2x to the 4th times 1 is just 2x to the 4th. Put it in parentheses and subtract. Now, when you subtract, these go away. What's 0 minus 2x? So that's -2x to the 4th. You have to be really careful with the negative signs. Now I bring down the -x cubed plus 2x squared minus x. I do the same thing. -2, 1, 2, 3, 4. And I'm dividing by 2x. So the 2's go away and an x goes away. I would write -x cubed up there. And so -x cubed times 2x is -2x to the 4th. -x cubed times the 1 is -x cubed. So now when I put this in parentheses and subtract, this goes away and this goes away because they're identical. So then I have 2x squared minus x. Now this is a first degree, so this still has bigger degree down here. When you look at this, this is first degree here, and this is second degree. This degree needs to be smaller. So we keep going. So I do my 2x squared over 2x, and that goes away, that goes away. So we're going to write an x up top. X times 2x is 2x squared. X times 1 is x, but it's positive x. So when I go to subtract, these go away, but you have to be careful. This is a parentheses, by the way. Negative x minus x ends up with 2x. So then, we're still not done, so I go negative 2x divided by 2x. Those go away, and I'm left with negative 1. Then you go negative, multiply the top, negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. Put that in parentheses and subtract. And these go away, and I'm left with positive 1. So a remainder of 1. And some people write it 1 over 2x plus 1. So look that over and see what you think. In this next problem, you're supposed to find only rational zeros. So if you need to make a P over Q list, do so. But I would start by typing this into your graphing calculator, see if it hits any numbers that are nice, do your synthetic divisions. So right now, let's treat this as a DIY. Pause the video now and see if you can find them. So again, what this is saying, if you look at the graph first, you probably will see that you think it hits negative 3. Do your synthetic division. It works, 0. Then do 1. Just use the numbers at the bottom and do 1, and you're going to find out it's 0 again. So this is a remainder. Now there's one that's hanging out in the middle. It actually is the 1/2. But what you can do then, this is your constant, and this is your x. So look, you can set up a linear equation right here. 2x minus 1, set it equal to 0. And when you solve it, that's how you get the 1/2. So you might not see that. But remember, 1/2 is rational. So these are your 3 rational zeros. So I typed this into my calculator. We're going to go ahead and look at the graph. Now, remember, this is an x cubed graph, so it should be S-shaped. So when it's doing this, I know that it should be coming up and hitting somewhere off the screen. Should be hitting somewhere off the screen. So it should be making an S-shaped curve. So basically, on our graph, we're only seeing this much. We're missing something else. So go ahead, see what we can do to find some zeros. So it kind of looks like maybe it comes up and bounces at 1. So let's go ahead and take a look at that. So I can do 1, negative 53, 103, and negative 51. I'm going to put a 1 out front. So the 1 drops through. 1 times 1 is 1. Negative 52. 1 times negative 52 is negative 52. That'll be a positive 51. Multiply by 1, I get 51, and I get a remainder of 0. So that did work. So let's do it again. Put a 1 out front. The 1 will drop through. 1 times 1 is 1. That's negative 51. Multiply by 1, negative 51. I get a remainder of 0. So what's happening then is I would take this piece right here and call it 1x minus 51, set it equal to 0. Add the 51 to both sides, and I get x is equal to 51. So further down, it's hitting at 51. So if I would do a window and extend my maximum to something like 55, I can see it go down, and then it comes back up way down the graph. So that's how you could do that one.